Welcome to CBS Easy.
Hey everyone, and welcome. We are about to break down one of the most important topics for your board exams, areas related to circles. By the end of this, my goal is pretty simple. I want you to feel totally confident and ready to nail any question about sectors or segments they throw at you.
So, sectors, segments, they sound kind of the same, right? It's super easy to get them mixed up. Believe me, a lot of students do. But stick with me here because we're going to clear that up for good. You'll know the difference inside and out, and you'll know exactly how to handle these questions.
Okay, here's our game plan for today. First, we'll nail down the basics of sector versus segment. Then, we'll get into the formulas you need to know. After that, we'll solve the segment puzzle by walking through a real exam problem step by step. And we'll wrap up with a super quick recap and some really important exam alerts. Let's do it!
All right, first things first. Before we jump into any calculations, we have to build a solid foundation. Let's get crystal clear on what makes a sector and a segment a segment.
You know what they say? A picture's worth 1,000 words. Just look at these two. The difference is all about what's creating the shape. The sector on the left, it's formed by two radii coming out from the center. The segment on the right, it's created by a single chord cutting across. That's it. That's the key difference.
Let's start with the sector. The easiest way to remember this, just think of a slice of pizza. Seriously, it's the area bounded by two straight cuts from the center. Those are your radii, and the crust, which is the arc.
And this diagram shows it perfectly. That shaded bit, OAPB, is your pizza slice. It's made by the two radii, OA and OB, and the smaller arc connecting them. We call this the minor sector. The rest of the pizza, that big unshaded part, is what we call the major sector.
Now for the segment. This is different. Imagine you're not cutting a pizza slice from the center. Instead, you just make one straight cut across it. That area you've just sliced off, bounded by that straight line, the chord, and the arc, well, that's your segment.
You can see it right here. That chord AB just slices off a piece of the circle. The shaded area, APB, is the minor segment. It's not the full slice, it's more like that crusty end piece someone just cut off.
Okay, exam alert. This is a big one. If a question just says, find the area of the sector, or find the area of the segment, it is always talking about the minor one, the smaller piece. Remembering this little rule can save you from a really common and costly mistake. All right, now that we've got the basics down, let's talk formulas. I'm going to show you where they come from, because once you understand the logic, they become so much easier to remember, especially when you're under pressure in an exam. You see, this formula isn't just magic, it's pure logic. Just think about it. A whole circle is basically just one giant sector with a 360-degree angle, right? So, we take the total area, pi r squared, we divide it by 360 to see how much area one single degree covers, and then we just multiply that by whatever angle we're actually interested in. Theta. Simple. So here they are, the two big formulas for your toolkit. And notice how similar they are. They both start with that same fraction, theta over 360. You just multiply that fraction by the total you're looking for, either the total area for a sector or the total circumference for an arc. Okay, now for the segment. And here's the great news. You don't really need a whole new complicated formula. Finding the area of a segment is actually just a simple subtraction problem. The logic is just beautiful. To find the area of the segment, that crusty end piece, all you do is find the area of the entire pizza slice, the sector, and then you just subtract the area of the triangle inside it. It's always sector minus triangle. This picture shows you exactly what I mean. The whole shape, OAPB, is the sector. The triangle inside is OAB. The segment we want, that shaded area, APB, is just what's left over when you take that triangle away. Remember that, and you've got the key to solving these problems.
Theory is great, but let's get our hands dirty. We're going to apply everything we've learned to a typical 3-mark question, the exact kind you're going to see on your board exam. Let's see how all the pieces come together.
So, we're grabbing example 2 from the NCERT textbook. Here's the situation. We have a circle, its radius is 21 centimeters, and the angle at the center is 120 degrees. The mission? Find the area of the segment AYB.
A question like this can look a little intimidating, I know, but we just break it down into 3 clean, manageable steps. Step 1, find the area of the whole sector. Step 2, find the area of that triangle inside. Step 3, subtract. That's it.
Now that second step, finding the triangle's area, is where things can get a bit tricky. The triangle OAB isn't a simple right-angle triangle. So what's the strategy? The key move, as shown here, is to drop a perpendicular line from the center O down to the chord AB. This genius move splits our triangle into two identical, easy-to-solve right-angle triangles. And now we can bring in our old friend trigonometry to find the base and height.
So, once we've calculated the sector's area using our formula and the triangle's area using a bit of trig, we do the final subtraction. Sector area minus triangle area. And that gets us to our final answer, right here on the screen. A quick tip, always double-check if the question wants you to leave root 3 as it is or substitute its value.
Whew, okay, that was a lot. So before we wrap this up, let's do a super fast summary of the absolute most important points you need to lock in for your exam prep on this chapter.
Here you go, your final cheat sheet. Sector is the pizza slice, made by 2 radii. Segment is the crusty end, made by 1 chord. Know the sector formula by heart, and always remember the segment is just sector minus triangle. And please, don't forget the minor rule.
Okay, one last critical alert, this one for your MCQs. Be ready for questions that try to trip you up by changing the letters in the formula. They might use P for the angle instead of theta, or a capital R for the radius. They do this to make sure you actually understand the structure of the formula, not just that you memorized a string of letters.
So, let's put that to the test right now with a final challenge, pulled straight from your textbook. The question asks for the area of a sector, but it uses angle P and radius R. Take a close look at the options. Which one is the correct one? Think about the structure we talked about. You've got this. Good luck.
Thank you for watching with us. See you next time.